Good day, good morning, good afternoon, and maybe good evening, ladies and gentlemen. My name is Tian Dao. Welcome to this 6 gigahertz IMT opportunity for society webinar. And before we start, there's a few housekeeping issues that I would like to inform you. First, how to do Q&A. And as you can see on your web browser, there's a chat box on the right-hand side of the web browser on your right-hand side, and you may type questions there. And please submit questions or advise us of a technical issue at any time during the broadcast via the chat box located on the right-hand side of the browser. And now let's get started. So, welcome. The deployment of 5G will bring large benefits to mobile services and users over the coming years. Allocating spectrum in the 5925 or 6425 to 7125 megahertz band for 5G NR and its evolution is a critical building block, making it economically feasible to offer 5G services at a price point that is affordable to all income groups. Starting with the existing trend and anticipating further evolution in the longer term, this fourth webinar on the topic elaborates on the importance of making more spectrum available for IMT as an essential means to achieve the 5G vision in developed and developing markets. It considers the fact that the 6 gigahertz mid-band spectrum represents a very strong candidate band for this purpose. Today's webinar is divided into a few sessions as listed here. And first, we are going to have Mr. Stefan Ziegler from Colliago to give us a keynote speech with regards to the 6 gigahertz band for 5G. And then I am going to moderate the regulators corner. We will have regulators from China, from Russia, from Slovenia, from South Africa, and Australia to explore their views on the 6 gigahertz band. And then I will turn it over to my colleague, Mr. Christian Gomez, and he will be moderating the industries corner. And afterwards, we will have the Q&A session. And as I stated before, please do type in any questions from now to the chat box. And now, let's welcome Mr. Stefan Ziegler. Please, Mr. Ziegler, you have the floor. Thank you.
Yes, hello. So my name is Stefan Ziegler from Colliago Consulting, and I'll be introducing the study we have done on the demand for spectrum and specifically the benefits of the 6 gigahertz band for mobile and FWA. Next slide, please. So I look at the need for more IMT mid-band spectrum to realize the 5G vision, then introduce how we modeled demand and area traffic density, and look at area traffic capacity on the other hand, and then bring the two together in 5 cities. And then I'll take a quick look at the role of the 6 gigahertz outside cities for FWA. Next slide, please. So the key question is there a need for more upper mid-band spectrum for IMT? And specifically, we examine the 6 gigahertz mid-band spectrum from 5925 to 7125 megahertz as a candidate band for this purpose. Next slide, please. First of all, there's always a debate, is 5G just another G? Is it simply an evolution or is it a revolution? And I think broadly speaking, LTE was about people with smartphones, but 5G is so much more. It's, yes, smartphone, but better, higher benefits and so on, but it's also fixed wireless access, massive machine type communication, and critical machine type communication. And the 5G vision is for ubiquitous fiber-like user experience and connectivity, and for a wide range of new use cases. So, and one of the key points is an expectation of a near guaranteed data rate seamlessly. Next slide, please. Now, looking specifically at the IMT 2020 requirements, this is what ITU-R has defined as 5G. This is what all countries around the world signed up to. So if you compare the user experience data rate, LTE advanced versus IMT 2020 I5G, we'll see that the user experience data rate is supposed to be 100 megabits. That's a factor 10 increase from today. So I'm sure you agree, this is a step change rather than evolution. And when we look at area traffic capacity measured in megabits per square meter, the requirement is for a 100-fold increase. So the vision for 5G is that it should provide 100 megabits user experience data rate anytime, anywhere, whilst on the move. Next slide, please. And it is these two requirements that drive the need for spectrum. There's, of course, a wide range of spectrum resources required for coverage, capacity, and so on. But specifically, we're looking at upper mid-bands for citywide speed coverage and 5G only to deliver the user experience data rate. Of course, you also need other spectrum, high bands, millimeter wave, 26 gigahertz and higher. You need that for traffic hotspots to deliver the area traffic capacity. Next slide, please. So our model starts with the ITU requirement. If you're selling speed, you have to deliver speed. So 5G means that user experience data rate of 100 megabits. So that's our starting point. We then use population density as a proxy. Broadly speaking, traffic density are proportionate to population density. But of course, not everybody needs 100 megabits at the same time. So we then look at concurrent demand from human and non-human users in form of an activity factor. But we also must take account that some of the traffic will not be on the upper mid-band spectrum. There will be millimeter wave, so we have an offload factor. This gives us a traffic demand per square kilometers in terms of gigabits per square kilometer. On the supply side, we have the macro sites, we have the small sites, and we have assumed substantial densification and maximum sectorization. We assume that all of the spectrum available will move to 5G and deployed on all sites, and we make appropriate assumptions for spectral efficiency, taking account of higher orders of MIMO. This gives us the capacity supply per square kilometer. So we have demand and supply. Next slide, please. So first of all, let's identify the high density areas. And we have taken here Tokyo as an example. So the high density area is not necessarily the administrative boundaries of a city, but here, for example, we have identified an area within a contour line of 70,500 people per square kilometer. Within that, the density is 19,440 people per square kilometer within an area of 173 square kilometers. So a fairly sizable area. So that's the population density in Tokyo. And you can see it is pretty dense. Next slide, please. Here are the other cities for which this sort of thing might apply. This is a sample of urban areas in the APAC region with population density of over 9,000 per square kilometer. And you can see the cities I picked here, they're not really the usual suspects. They're cities which are far, far higher density. But what I like to illustrate here is that this is really relevant for all APAC countries. In all of your countries, you find urban areas with a population density above 9,000 per square kilometer. And I think that there are at least 150 urban areas with significant populations which fall into that category, encompassing a population of around about 500 million. Next slide, please. Now, how about the activity factor? Well, we know, of course, demand is going up. People are watching video, they're watching it for longer. So the activity factor represents that. That is more bandwidth for a longer time. And as smartphone usage is heading towards fixed usage, we can see that the demand for the busy hour extends, and so the concurrent use extend. And using population density as a proxy, we also add in demand from non-human users where such devices exist. For example, cameras, connected cars, and all sorts of things. So that is encompassed, all of this is really summarized in the activity factor. Next slide, please. On the supply side, what have we assumed for the network? For macro sites, an intersite distance of 400 meters, 3 sectors per site, and you can see here the values you have used for the downlink spectral efficiency. The amount of spectrum available varies a little bit. Now, we have not taken the spectrum that is actually assigned, because that might be lower in certain countries, but we have taken the spectrum that's actually available and could be assigned. So that's the IMT spectrum identified, and whether also, or there are specifications. And so we have 190 megahertz in below 1 gigahertz, and then we have the mid-band, typically 460, and more in the upper bands. We have also assumed densification through small cells in the model to give additional capacity, because that is a trend that will happen over the next 5 years or so. Next slide, please. So we can then compare traffic demand in terms of gigabits per square kilometer with capacity supply and see, do we run out of spectrum, or how much more spectrum do we need, assuming a reasonable densification that is economically feasible. Next slide, please. And that is the result for Tokyo. Now, let me talk you to this chart. What we see on the horizontal here is the population density, and we located Tokyo on that line. And then you see on the vertical axis the traffic density and capacity in terms of gigabits per square kilometer. You also see some upward sloping lines. These upward sloping lines, the colored line, represent the demand with varied activity factors depending on population density. So the higher the population density, the higher the area traffic demand, and the higher the concurrent use, that also increases the area traffic demand in terms of gigabits per square kilometer. And then we have the capacity supply. The first scenario, the lowest line of the dashed back line, that's if 6 gigahertz is not available. Then capacity supply if 700 megahertz, the upper bit of the band, is available. That's the other dashed line. And the top dashed line if the entire band, the entire 1.2 gigahertz is available. And you can see where these colored line cross the population density, Tokyo population density line, this is the amount of spectrum you need. So you can see if the capacity supply is not increased, we can accommodate an activity factor of 10%, but if it goes to 15%, we are in trouble. And if it goes to 20%, we are in big trouble. So I would say that certainly Japan or Tokyo would benefit greatly from having at least the 700 megahertz available. And I must say this, Tokyo is in a fortunate position because there is actually in Japan a lot of upper mid-band spectrum available. There are other markets where this isn't the case, where the demand for upper mid-band spectrum of 6 gigahertz is higher than that. Next slide, please. Of course, one of the use cases for 5G, and this is highly relevant for emerging markets, is fixed wireless access, 5G fixed wireless access. This is really taking off in an unprecedented way to bring broadband connectivities to homes and businesses. And you can see it's in fact the fastest growing broadband connectivity technology in 2019 and will continue to be so. Next slide, please. The other trend we are seeing is the end of copper. The switch of copper has started in many countries. And I would say this, in many APAC countries, such, for example, India, Bangladesh, and so on, you haven't got much copper to begin with. And if you then want to build fiber in rural to all premises, this is hugely expensive. The cost of bringing connectivity using FWA is 50 to 80% lower compared to building fiber. So this is why, if rural connectivity targets exist, this is usually associated with subsidies. So the message here to governments or regulators is, if there is sufficient spectrum around to really help broadband FWA to take off, this will reduce or may even eliminate subsidies to bring broadband to rural areas. Next slide, please. So what we looked at is what data rate would we require for an FWA connection, and we assumed, for example, 100 megabits. What's the concurrent use? We assumed a higher factor, as is the case for fixed connection. We assumed a factor of 50%, and then we looked at the amount of spectrum deployed on the cell tower, and this gives us the required number of connections per cell tower for positive FWA business case. So how many can we support? That's the key question. The more we can support on the cell tower, the better the FWA business case. Next slide, please. So what we find, the more spectrum we have, the more households we can support at a given quality of service, in this case, 100 megabits. So if we only have 400 megahertz in the 3.5 band, we can only support 220 households, but that goes up to 381 and 496 if we have 700 or 1.2 gigahertz of 6 gigahertz spectrum. And so really, because the business case is so much better as we have more spectrum, what does it mean? It means it becomes cheaper for operators to provide it. It becomes more affordable. And so the having additional spectrum for FWA, particularly in developing countries, is therefore crucial to bring down the cost of broadband connectivity. Next slide, please. We already know that in emerging markets, India, Bangladesh, Indonesia, in access to the internet, voice communication, everything is really wireless. Wireless dominates. So 4G networks today, 5G networks tomorrow. So if you were to assign the 6 gigahertz for unlicensed use, as the Americans have done, the entire band went to unlicensed, you're not really solving the connectivity problem, because there is nothing to connect it to. If you want to use it for Wi-Fi, first of all, you need a fiber connection to a home to then distribute the Wi-Fi signal, but this doesn't exist. So in developing countries, the IMT identification for the 6 gigahertz band would deliver socioeconomic benefits, which would definitely not be the case if the 6 gigahertz band is used for unlicensed i.e. Wi-Fi. So I'm not saying that the US didn't make the right decision. That's fine for their markets. There's plenty of fiber around. So that may make sense. but for sure, I would say in developing countries, it doesn't make any sense at all. And the use of 6 gigahertz for IMT would deliver huge benefits. Next slide, please. So you can always email me with your questions. And if you want to have a copy of the report, I think the organizers of the cinema webinar make it available. Or if not, please send me a mail. And that concludes my presentation. Thank you very much.
Thank you, Stefan, and thank you for the statistics and the interesting diagrams. Thank you. And okay, let me check. As planned, we were going to have Ms. Zheng from MIIT to introduce the slides, but her previous meeting is running overtime, so let's wait for let me put her in a later slot, and then let's welcome Mr. Sergey Rudko from RCC. And Mr. Rudko is the RCC coordinator on WORK 23, WRC 23, agenda item 1.2 and 1.3. Is going to give us some brief ideas on the rationale of the 6 gigahertz bands in Russia and RCC area. Thank you. Please, Mr. Rudko, you have the floor.
Good day to everyone. My name is Sergey Rudko, Russian Federation. I am the RCC coordinator on agenda item 1.2 of WRC 23. And I would like to present you some information with regard to mid-band issue in the RCC countries. Having dealt with mid-band, we have a lot of opportunity with respect to the balance of great data speed together with wide coverage of IMT. And taking this, the issue of allocation mid-bands for the IMT have been considered at previous WRCs for some bands, in particular from 3 to 6 gigahertz. Okay, and we know what some bands was allocated and identified for IMT. However, decision did not satisfy all countries, in particular some countries in RCC, due to number of limitations with respect to compatibility with other services. And the RCC organization were one of the regional group who proposed at WRC to consider mid-band, especially we propose 6525 to 7100 megahertz. Take it into account that in the 3 gigahertz range, we have some difficult for implementation for IMT due to wide use of fixed rate service in some RCC countries. And therefore, the RCC countries consider this 6 gigahertz band as one of the key band for the development and launch 5G in RCC region. Currently, we conducting studies for harmonization of 6 gigahertz band. Next slide, please. Okay, so you can see our preliminary position on agenda item 1.2 for 6 gigahertz band. Actually, our position is divided to 4 bands. You can find what RCC administration are in favor of identification of IMT, but at the same time, we need to ensure compatibility with other systems and service. And IMT systems shall not impose additional regulatory or technical constraints on the services having primary allocation in this frequency band. So this is our position as it is was approved at the previous RCC meeting. So next slide, please. Oh, you can see the basic RCC countries' current usage in considered band. We have the fixed service microwave link, actually have more than 1,000 stations, and coordination may be required with them, but we mostly located outside cities. And FSS geostationary uses we have mostly in first 100 megahertz band, and for other spectrum, it is limited usage of geostationary FSS. Also, we have no geostationary FSS, but we have a very limited number of operation systems. And also, we have Space Operation Service and ISS passive we need to protect, and we have a limited number of radio astronomy service located outside cities. In 2020, in RCC, there was a questionnaire on 5G spectrum use and planned. And regarding the answering, the Russian Federation has identified all these band as interested and future planned. And in accordance with the Russian regulation work plan for 2021, the full scale test of 6 GHz IMT equipment are planned. So also I would like to say that the RCC country already has sent the license statement to the 3GPP to invite 3GPP to consider this frequency band in 3GPP specification for IMT 2020 in order to ensure timely availability of 5G new radio equipment to enable the deployment of IMT 2020 system in our RCC country. So with that, I want to conclude my short presentation. Thank you.
Thank you, Sergey. Thank you for the presenting the RCC and the positions and the details. And now, may I introduce you to Ms. Meta Pavšek-Taskov from ARCOS, Slovenia. She is the head of mobile communications. She's going to introduce from Slovenia's perspective, finding the right balance for the future shape of 6 gigahertz. Meta,
good afternoon, everyone. Thank you. Good afternoon, everyone. My name is Meta Pavšek-Taškov, and today I will present a Slovenian vision of finding the right balance for future shape of 6 GHz band. At WRC 19, Slovenia supported new work item for study and possibly identify the frequency band 6425 to 7125 for IMT. COVID crisis has shown the need for more spectrum. Operators reported increase of traffic as much as 30% in peak hours, and in some regions even up to 200%. Operators are optimizing their network capacity to keep up with traffic spikes. Nevertheless, the majority of operators reported lack of spectrum and the need for spectrum award as soon as the COVID crisis stops. Next slide, please. So this slide shows the situation in Slovenia. Can you go one slide back? Yes. On the left, current situation, and on the right, the proposed spectrum for new multiband auction, which is now in process. We will auction 700, 1500 megahertz and 2.1, 2.3, 3.6 and 26 gigahertz band. For the future, we believe that the only possible candidate for CPT could be the 6 gigahertz band, as the 2.6, 2.3 and 3.6 has already been assigned or is in the assignment process. But unfortunately, in a lot of CPT countries, the band 4.4 to 5 is not available. Next slide, please. So the auction spectrum will solve the spectrum needs for first 5 to 7 years, and will offer enough spectrum to support high capacity citywide connectivity. But in second phase, 5 to 7 years, we believe that at least 200 to 400 megahertz per operator would be required. This is because of expected fast growing of traffic with square or even with exponential curve, driven by new applications such as HD, UHD video, augmented virtual reality, fixed wireless access, the unlimited data tariff plans, and as well as accelerated investments in e-health care, smart home, smart cities, smart manufacturing, driven by COVID-19 crisis. Next slide, please. How can be assured that requirement of satellite and other incumbent services of the mid-band spectrum are fully taken care of? We believe that coordinated use of or licensed use of this upper 6 GHz band can ensure the coexistence with fixed service. For the fixed satellite service, there is a need to review the report S2367 done in WRC15 on sharing and compatibility between IMT to be upgraded with the new facts such as new technological features of 5G IMT, such as precise beam direction control for 5G active antenna systems, high bandwidth, and low power spectrum density. And the new recommendations produced in this time period. For example, the recommendation for Earth-to-space clutter loss, Earth-to-space propagation, and building entry loss. Work is ongoing in ITU and 3GPP, and IMT and incumbent parameters and models are in development. Next slide, please. So Slovenian vision on the use of 6 GHz band in Europe. The lower frequency band has already been harmonized within CPT for unlicensed use in accordance with ECC decision 2001. And the upper, we believe the license for IMT would be better solution due to better protection of fixed and fixed satellite services. We also believe that the band upper 6 and 3.4 to 3.7 are complements as they have similar propagation conditions and situation regarding satellite networks. So the 3GPP band N78 is satellite uplink, and it's paired with satellite downlink 3.4 to 3.7. We believe that the right balance between airline and IMT should be kept in 6 GHz band. Wi-Fi speed bottleneck lies in the backhaul part, e.g. fixed network or even 5G, and Wi-Fi cannot provide guaranteed quality of service. We see that Wi-Fi can be more like as a complement than an alternative to 5G. Next slide, please. So to conclude, there is a need for more spectrum in midbands, enabling large enough bandwidth for higher throughputs and other use cases for mobile operators. The band will be used in the next 5 to 7 years. The lower 6 GHz band has already been harmonized for VAS airline license exempt use in accordance with ECC decision 2001. We propose for upper 6 GHz a license approach, as we feel that this frequency band could be used similarly as the band 3.4 to 3.8 megahertz. We believe that the bands are complements. The licensing approach for upper band will better protect incumbent services. Therefore, the license used for IMT in upper 6 GHz bands is our preferred solution. Next slide, please. Thank you very much.
Okay.
These are my contacts for possible questions.
Okay. Thank you, Meta, and thank you for the introduction on the Slovenian perspective. And now we have Mr. Richard McGotoho from South Africa. He is a radio communication specialist from South Africa administration, and he's going to talk about the 6 gigahertz opportunities for Africa. And Richard, you have the floor.
Yes. Good morning, colleagues. Good morning, and thank you very much for the opportunity. The next slide. My name is Richard Makgoto from the Independent Communication Authority of South Africa, the regulator. The next slide is just an overview of the presentation. Will give you an overview, opportunities for Africa, activities in Africa on WSA Agenda Item 1.2, IMT 2020 deployment planning, and some recommendations. Next slide is the overview. We would recall that at WSA 15, there was an African common proposal seeking the inclusion of the lower bands, which was around 10 gigahertz, among those to be studied for IMT under the new resolution 238. This was WSC 15, but unfortunately, that was not to be. And therefore, WSC 23 offers an opportunity to revisit this regional consideration, and therefore are to consider future spectrum needs for IMT in Africa at its meeting of August 2019, which was held in South Africa, in preparation for WSC 19. And therefore, the band 6 gigahertz was submitted as a common proposal to WSC 19 for inclusion as a future agenda item. And therefore, it is expected that IMT 2020 systems in millimeter waves will be mostly deployed as hotspots in big cities and densely populated areas. However, in order to enable the full capabilities of IMT 2020, including extended coverage, additional spectrum will be required, in particular in the middle bands, hence the inclusion of the 6 gigahertz. So therefore, the African region submitted proposal to WSC 19 to consider IMT identification in the frequency band 5925 to 7125 megahertz for inclusion as a future agenda item, which is currently agenda item 2. And this was one of some of the bands which are included in the for future agenda items to ensure that sharing and compatibility studies are undertaken within the ITUR leading towards the WSC 23. And therefore, WSC 19 resolved to include in WSC 23 agenda item 1.2 consideration of IMT identification in the frequency band 70 to 25 to 7125 megahertz on a global basis. And then in particular for region 1, 6425 to 7025 megahertz in the region 1. And it is on this basis that the African region supports fully the identification of this particular band. Next slide, please. Yeah, the key benefits for Africa that we envisage is that once it is globally allocated the mobile service on a primary basis, this could increase the ecosystem and it will result in the economies of scale. There will also be a good balance between coverage and capacity, which is similar to the frequency band 3 to 5 gigahertz. There's also large bandwidth available within the frequency band, and the economies of scale in region 1, including if and once included in China under the footnotes and other countries, there will be large economies of scale in this respect. And therefore it will benefit Africa in that respect. Now, in addition, for a mobile operator to compete effectively and provide full bouquet of 5G services, it is a fact that it will require spectrum in the range of sub 1 gigahertz, the mid bands, and the high band. And in particular, the mid band is the one that is fairly will give more benefits to the achievement of the 5G capabilities. And therefore, it is expected in Africa that mobile broadband and fixed wireless access will be the main services that will benefit from the 6 gigahertz. This is due to the fact that in Africa, we have a low fiber and copper penetration, and therefore fiber wireless access is a key technology to improve the coverage for fixed broadband in African homes. Next slide, please. Yes, yeah, so just in terms of activities under Agenda 1.2, where under which the 6 gigahertz falls, the African group had its first meeting in August of this year, and they've developed a structure, and this structure is as illustrated, and this agenda item 2 is undertaken under working group 1 of the APM, and therefore these are the structure as it stands. It is led by ECAS, which is the region up north, with the vice chair, IACO, and ECOWAS. And therefore, the African group endeavors to participate actively and contribute to the studies and work undertaken by the ITUR Working Party 5G under agenda item 2, and under which the 6 gigahertz fall. The African group also intends building on experience gained in the last study cycle, where shared studies were concluded within Working Party 5G for the frequency band 3.3 to 3.4, which resulted in the identification of IMT at WRC 19. Next slide, please. And therefore, it is important, if we go to the next slide, it is important for the deployment of IMT that in the, we need to ask the following question as to why is Africa needs to be involved in matters regarding 5G. And we also need to look at the relationship between appropriate spectrum and standardization in Africa, and ensure that the standardization gap that exists between developed and developing countries as identified in Resolution 44 of WTSA 2008 is actually closed. I think it is high time that Africa really participate actively and contribute meaningfully to this development, in order to make sure that there's a bridge in the standardization gap. Next slide, please. Yes, yeah, so we actually recommended that the African countries, in order to be able to benefit in economies of scale, it is important that the African countries participate actively and ensure that they are abreast with technology developments and to better reflect the requirements and interests of developing countries in the standardization process. And also to facilitate the increased participation of developing countries in standardization, so as to ensure that developing countries experience the economic benefits associated with technology development and to better reflect the requirements in the standard development process. This is to ensure that to close the gap between developed and developing countries with regard to spectrum management, planning, and the standardization process. With this, let me submit with the last slide, and thank you very much, Mr. Chairman. Thank you, Chair.
Thank you, Richard, and thank you for nominating as the chair. Right, thank you. So our next speaker is Mr. David Goggin. He is from the Australian regulator, APAC. He's going to briefly touch on the 6 gigahertz band. So, Mr. Goggin, you have the floor.
Thank you, and thank you to GSMA for inviting me to speak today. For my presentation, I'll provide an overview of what we're doing from a regulatory perspective in Australia with regards to the 6 gigahertz band. Next slide, please. The general process we follow when reviewing arrangements in a band is shown on the slide here. We're constantly monitoring international developments regarding the use of radio frequency spectrum and talking with domestic stakeholders to understand their evolving needs. Based on any developments and feedback we receive from industry, we then determine whether to progress consideration of a particular band to the initial investigation stage. Some of the triggers here could include international spectrum harmonisation, technology standardisation, developments in other countries that could help develop economies of scale or could result in likely economies of scale for equipment, as well as the domestic spectrum planning environment and demand drivers as well. So the initial investigation stage usually involves a public consultation process. The intention is to detail current uses of a band and any drivers for change that we're aware of. It also acts as an information gathering tool, so interested stakeholders can provide us with other information that may be relevant for consideration to a particular band. Any feedback we receive helps us to understand the issues associated with a band, and also helps to inform the next steps in a review. This could include whether or not we proceed any further with it. If a decision is made to proceed, we then move to the preliminary replanning stage. This stage usually involves another public consultation process, and it includes identification of detailed planning options. And these consider the needs of incumbent services, the impact potential changes may have on them, and possible alternative spectrum options if and when appropriate. Based on feedback to that stage, we then make a decision regarding what, if any, changes will be made to a band. We then move on to the implementing any of those changes. Next slide, please. So at the moment, we're in the monitoring stage of the 6 GHz band. We've been following developments in a number of different countries like the UK, Europe, the US, South Korea, and also been monitoring what's happening at the ITU in regards to WRC agenda item 1.2 as well. So based on that and some of the growing interest domestically in accessing this band for potential wireless broadband applications, we're planning to move to the initial investigation stage, planning to release a consultation paper this quarter. This paper will look at both the 6 GHz band as well as existing arrangements in the 5 GHz band. With regards to the 5 gig band, that's really looking at some of the outcomes of WRC, the last WRC 19, for example. With regards to 6 GHz band, we're open to a range of different options, but no decisions have been made yet. We're looking at possible RLAN use, as well as fixed wireless access or mobile wireless broadband use in the band as well. Obviously, that's any decisions that we make here will take into account incumbent services in the band as well. Based on the feedback we received for this paper that we'll release, that'll help inform our next steps in regards to the 6 GHz band. Next slide, please. So this gives you a bit of an idea of the current environment within Australia. We have a number of services currently operating in there. Substantial use by fixed links. We've also got satellite uses as well, radio astronomy. So all these services will need to be taken into account in any planning decisions or any work going forward. And whether or not there's coexistence issues, whether coexistence is possible, or whether or not we need to look at other options for either mobile wireless broadband or wireless broadband services or incumbent services as well. But this first paper that we'll release will help us to get a better understanding of all the issues in the band before we proceed to going down any further paths investigating options for the band. And that's it for me. Thank you once again for inviting me to speak.
Sorry, I was talking while muting myself. Okay, before we move to the next session, we do have another important speaker on the list. And let me just go back to the first set of slides. And we do have Ms. Zheng from MIIT China here. And let me just give a brief introduction of Ms. Zheng. Ms. Zheng Fansheng, she is the Vice Director of Frequency Planning Division in the Radio Regulation Bureau of of MIIT, and she is going to introduce the 6 gigahertz frequency band consideration in China. And Ms. Zheng, you have the floor, please.
Thank you. Is my voice okay?
Yes, loud and clear.
Okay, thank you. Good afternoon to all colleagues, and my name is Jinfan Shen from MIT of China, and I'm very pleased to be here to share some 5G spectrum management and future consideration in 6 gigahertz with you. And this slide shows the 5G frequency assignment in China now. And we have there's 4 mobile network operators has gotten totally 680 megahertz bandwidth to deployed 5G system now in China. And for frequency band, the 3.3 to 3.4 gigahertz band, they authorized only limited to indoor deployment for 5 MOP mobile network operators. And we're refarming the 2.6 gigahertz band as the slide shows, and also the 700 megahertz band greatly, and this 2 frequency band greatly expands available spectrum for 5G systems. Next slide, please. Okay, here is the radio regulation timeline in China, and this, from the WRC7, we start frequency planning preparation after WRC 07 meeting, and the tier 2017, we complete the releasing frequency planning for 5G system. And 1 year later, we issued 5G frequency band trial license. So from this timeline, we see that it usually takes long time to prepare new frequency bands before releasing to. So it is recommended that earlier planning for future MT spectrum development is needed. Next slide, please. Yes, thank you. So of course, this slide gives some processing 5G system deployment in China. As we know that the Earth station in above mentioned frequency bands would be affected by 5G system. So in order to resolve this problem, the interference, we established the procedure and frequency correlation and protection standards. Till now, nearly 95% of affected Earth stations has complete the technical update or migrated to upper bands. So by the end of last year, we have deployed 0.7 million 5G base stations in all the cities, and more than 250 types of 5G terminals get certifications, and 180 million terminals accessed into 5G base stations. Nowadays, people can enjoy remote education, 8K ratio TV, and intelligence transportation, online office, etc. by 5Gs. And among all kinds of successful applications, we found more and more convergence of ICT and 5G technologies for industrial international scenarios. Next, please. Thank you. So we think that according to the 5G visions and the characteristics of radio wave, we think that the appropriate frequency bands for 5G should including the lower frequency band and the medium frequency band and also the high frequency bands. All these we can meet all the requirements for our society. Next slide, thank you. But why we focus on 6 gigahertz band? Why 6 gigahertz band is the candidate frequency band for 5G? We think that this conclusion is based on the consideration from the following aspects. First one is 6 gigahertz band have good propagation property and more contiguous bandwidth. Second, we can achieve the balance of capacity and convergence in this band. Also, we can meet different requirements in most scenarios. Next is that this band will be more easy to extend existing 5G commercial network. So we think that this made the 6 gigahertz is very important for 5G development. Of course, we note that for this frequent band, there are some FSS deployment, but it could be foreseen that in order to improve the capacity and the application, more and more usage of FSS will migrate from lower band to upper band to obtain the high throughput. So FSS in this band, there is another reason that FSS in this frequent band is uplink. So we think that this deployment make it easy to find the coexisting solution. Next slide, thank you. And we know that for the WRC 2023, there is a agenda item focused on the 6 gigahertz band in the future. And we are in favor of the identification of this frequency band for IMT with the appropriate technical conditions based on sharing and compatibility studies with regard to the related services. So we also welcome all the interesting countries or companies to join the study and the this year, from last year, we studied the conducting of the revision work of the national frequency allocation table based on the new vision of ITU-R radio regulation, and also considering some domestic needs. During this work, as the IMT sector members proposed the administration to identify the frequency band from 5925 to 7125 megahertz in the new revision to MT. We are considering to accept this proposal now. And meanwhile, we are also considering to give the spectrum license to facilitate 5G test and trial in the same band. We think that this is what I want to sharing with you, and thank you.
Thank you, Ms. Zheng, and those considerations you presented is certainly encouraging. And before we enter so now we have finished the regulators corner, and the next step, the next session will be the industries corner. But before we enter into the industries corner, I would like to remind you that all questions can be raised, can be submitted via the chat box on the right-hand side of your browser, and I encourage you to start typing in those questions. And so now, Christian, you have the floor. Thank you.
Thank you very much, Kian. Can you hear me okay?
Yes, I
Great.
can hear you loud and clear.
Good afternoon, good evening, everyone. My name is Christian Gomez. I'm Director of Spectrum Policy and Regulatory Affairs for Asia Pacific at GSMA. And in this session, the Industry Corner session, we're going to have great speakers from 6 companies representing various angles of the mobile industry. And as an opener, as an introduction to the session, I would like to address the audience with a couple of slides. Next slide, please. So when we talk about 6 gigahertz and the solutions that 6 gigahertz can provide us, we're talking about affordable capacity. So far, the mobile industry has been extremely successful in connecting the world. We have over 4 billion connections worldwide. However, there is a gap in terms of usage where 3.3 billion live within a mobile broadband coverage area but are not connected. And this, let's take into account that in the 5G world, we are not connecting just people. We're also connecting machines with machines and machines with people. And this will certainly create huge demand over the next years. And coronavirus have taught us the importance of connectivity and infrastructure. And now industries and civil society are taking their activities online more and more. And for that kind of demand, we need enough spectrum supply. Now we have seen some very good data coming from the Coleago presentation, for example. And with this increasing demand, with this increasing data usage, we will definitely need to expand the bandwidth when it comes to mid-band spectrum. Mid-band spectrum is where we find the sweet spot between coverage and capacity. So the current allocations and the current assignments in 6 gigahertz, in mid-band spectrum will not be sufficient to cope with demand going forward across this the city type of deployment, and the demand will push us to look for 1 to 2 and even more than 2 gigahertz of additional spectrum. So we need to find that spectrum somewhere. And for countries that have limited access to a C-band in 3.5 and do not have access to additional mid-band spectrum, the question is, where are they going to find more spectrum to cope with the increasing demand? Next slide, please. WRC23 has been talked about already in a number of presentations, and we can see that across all 3 regions, there is an interest in mid-band spectrum. We can see in the graph there, regions 1, 2, and 3 are looking into the upper 4 gigahertz band, as well as the 6 gigahertz band in our region, specifically the upper part. But nevertheless, economies of scale can be found and can emerge from decisions in other regions as well. So we need to take that into account, that at the end of the day, decisions in all regions will have an impact when it comes to global markets. Next slide, please. So the global industry analysis, can we go back? Previous slide, thank you. In terms of our global industry analysis, we have surveyed our industry, and the responses to our survey show support for at least the upper part of the 6 gigahertz band as a high priority for the future of IMT in all 3 regions. Considering the survey and the demand from industry and service providers across all regions, the key message here is that harmonization is key, and economies of scale are expected to emerge from decisions in this band, in 6 gigahertz band, And WRC23 can help towards achieving this balance between demand and supply. Next slide, please. Further on the IMT spectrum demand, I will recommend to look in detail to our audience the IMT spectrum demand report, which is available from the Coliago website. In this report, you will find that one of the key findings is that a total of around 2 to 3 gigahertz of mid-band spectrum will enable operators to deliver the ITUR IMT 2020 requirements in cities in a way that is economically feasible. So let's remember that the more spectrum we have and the more bandwidth we can achieve through spectrum access, the more capacity we can deliver. In that way, we can match the demand and supply that we have seen in the previous presentation, and especially in the detail that this report provides. Next slide, please. This is the current landscape. WRC23 work has already started across all regions in terms of the preparatory work. Nevertheless, some decisions have already been made in some regions in terms of the use of the 6 GHz band. For example, in the band, we have various uses. One of them is backhaul. It is important to highlight here that the mobile industry relies on backhaul as well in order to deliver mobile services. So when we look at this band and when we look at allocating this band and securing this band for IMT, we know that regulators face a situation where they need to balance the different industry demands. There is one part of the discussion which is about protecting backhaul in countries that use backhaul links for the delivery of mobile services. So this is one angle which is important and must be remembered when it comes to evaluating how the band should be used. Now we have China that has successfully secured the band in full for IMT and to use it for 5G. Then we have Europe, where the bottom part of the band has been committed to unlicensed users, while the top part of the band remains under study and pending decisions of WRC23 for IMT identification. The United States has implemented a policy of allocating the band for unlicensed use in full. Therefore, APAC region, we have to make decisions based on the landscape and also take into account the local situation in every country, how much backhaul there is, the demands of mobile data use. This is quite an important angle as well. Here we see that some countries have already made decisions when it comes to unlicensed use. However, one point that we will raise when it comes to this decision is that mobility is key. The ability to have mobile data across the city will require infrastructure providers to have access to more spectrum, and the necessary bandwidth to achieve this is located in the mid-band, and the natural complementary band to the C-band in 3.5 is 6 gigahertz. Therefore, they need to take into account how this band will serve the mobility requirements of the city, because it's not all about the indoor type of use or the local area network type of use. Let's remember that as machines are connected with each other and people and machines connect with each other as well and interact. Infrastructure interacts as well in this landscape. Mobility is still the key, and it has to be a connection which is secure, reliable, and with the speed and bandwidth that the demand is pulling. So therefore, don't forget about the mobility aspect of the mobility requirement every city has, and 6 GHz will provide answers to those mobility requirements. Next slide, please. And just to close my presentation, some conclusions. When it comes to making decisions about the 6 GHz band, the GSMA believes that these decisions have to be made based on a market assessment, and this market assessment should lead the approach to the decision making in 6 GHz. When it comes to the bottom part of the 6 GHz, we should follow the developments and protect the backhaul that mobile infrastructure depends on in this band. We should consider the market conditions, and if required, consider a license use there, if required. For the upper part, we need to ensure that 5G has sufficient bandwidth to complement the 3.5 GHz band in response to the incremental data requirements and the requirements for mobility, considering network density as well as cost. We need to keep 5G deployments cost effective. Looking at market metrics as well is important. More 5G means that more mid-band spectrum will be needed. We need to consider options for 5G expansion in the future. So it's not all about the data demands or the mobility demands of today. We need to think about planning for the future. So this will require us to look at more options for the mid-spectrum, and 6 GHz is the natural choice. And finally, in terms of approach, it would be recommended to avoid decisions that cannot be reversed. So this is the case of decisions where unlicensed uses are allowed in the band. It's very hard to reverse those decisions later on once they are made. We need to also look at core network availability and 3.5 GHz availability. Let's don't forget about this key anchor band, 3.5. Not all countries have access to the 400 MHz of spectrum that, for example, Europe has made available in 3.5. And for those countries, there is even a stronger reason to look at 6 GHz as well. We also need to safeguard the top 700 MHz for 5G and consider the lower band. So there is also discussions about 600 MHz, for example, and what's the future of that? And I think that's a very important question because that's the sort of coverage layer to branch out to road. So let's not forget about that part as well. So thank you very much for your attention on this first part of the session on the industry corner. Now I'm going to move on to our panelists. So I will briefly introduce our panelists. First of all, we are very lucky to have a very distinguished group of speakers with us today. So we have Anna Matsuka from Ethno. Anna is a services regulatory and strategy. She's a senior manager in the strategy and regulatory relations division at Ethno, and she's also the chairperson of spectrum policy in the spectrum policy working group. We also have Xiang Sairang from CMCC. Xiang is spectrum program manager and 3GPP chief delegate. We also have Satish Jamadagni from Jio, massive company. Satish is Vice President of Network Planning, Engineering, and Head of Standards at Reliance Jio. We also have Mr. Hajar Saad from Axiata Group. She's regulatory specialist within the group regulatory affairs at Axiata Group. We also have Erika Tejedor from Ericsson, who is Director of Government and Industry Relations. And we have Ayman Moyeldin from Nokia, who is Senior Specialist of Standardization, Regulatory, and Spectrum. So in order to kick off our round of presentation from our panelists, we'll start with Anna Matsuker from Ethno. So Anna, the floor is yours.
Okay. Hello, I hope you hear me. Yes, okay. It's been a privilege to being part of this webinar, and I'm here today to speak on behalf of Ethno. Next slide, please. So who is Ethno? Ethno means European Telecom Network Operator Association, and Ethno represents Europe's main telecom operators who innovate and invest in the digital backbone. Ethno's mission is to develop a positive policy and regulatory environment, empowering the delivery of world-class services for European citizens and businesses. Ethnos consists of 32 members and 8 observers from Europe and beyond. Sorry. I have a problem with the video and it doesn't work well. So the members of Ethno are the backbone of Europe's digital progress. They deploy approximately 70% of the total fixed investment and 64% of the total mobile investment. Next slide, please. So, what's the status of 6 gigahertz in Europe? Regarding the lower part of 6 gigahertz, that part is being harmonized for wireless access systems and radio LANs on unlicensed basis. The allowed devices are low power indoor devices and very low power devices that can only be used outdoors. Harmonized the use of unlicensed equipment in Europe means that anyone in Europe can use the equipment without taking a permission. The low power device category is limited only for indoor use to avoid potential interference to existing use and, for example, fixed links. Of course, it is difficult to guarantee that the equipment is only used indoors because the users are not known. The upper part of 6 gigahertz is currently under study for IMT for WRC23 in Region 1, which Europe is also part of, as already stated by other speakers. Ethno supports this band for IMT opportunity. We believe that the feasible conditions for IMT use can be defined. Wider or global harmonization is also important for the ecosystem development and economies of scale. Currently, the main use in the band is fixed and fixed satellite service. And as already stated, the mobile operators are actually a current use of the band. It is an important band for backhaul in many countries. Next page, please. So, European operators consider the new mid-band IMT spectrum is needed in mid-long-term future. Demand is foreseen, especially in urban areas. Mid-band spectrum can provide hypercapacity, but also coverage for outdoor and indoor propagation. It is something that millimeter wave spectrum cannot provide, even though it is very high capacity services, gives very high capacity services at hotspots and fixed wireless access. Mid-band spectrum demand is driven by existing use, but also by new use cases that 5G is enabling. Mobile data use is been increasing all the time. When considering existing use cases, for example, media consumption, people may not consume much more time with media services, but demand increases due to higher resolution of 5G and new equipment enabled. In addition, 5G is expected to enable a set of new use cases. Typically, the introduction of new technology boosts the data consumption because it enables new things. This was the case also for 4G and 3G. We believe that the upper 6 GHz bands offer an excellent opportunity to meet the demand in Europe. We also believe that a licensed approach enables propagation of existing use where protection is needed. This is because the licensed approach enables setting limitations in the license. The users are also known, which ensures that they meet the license conditions. Because of this, we believe that the license approach would also allow higher transmission powers compared to what is allowed for airlines in Europe. That was my presentation. Thanks a lot.
Thank you very much, Anna. That was an excellent presentation, and it's very good to see that Europe is actively looking into the future requirement and emerging demand. Thank you, Anna. Next speaker, we're going to have the pleasure to hear from Shang Xiaorang from CMCC. Shang, the floor is yours.
Yes, thank you. This is Xiaoran from China Mobile, and the presentation today is prospects of the 6 GHz spectrum in China. Next slide, please. First, I would like to introduce the spectrum allocation in China. Currently, the 5925 to 7125 MHz is allocated for the uplink, the Earth to space satellite service. The corresponding downlink space to Earth C-band, which has already been reformed for the 5G NR. For example, in China, 3.3 to 3.6 gigahertz is already allocated to operators for the 5G NR deployment. Next slide, please. And in WRC 90, China's Ministry of Industry and Information Technology proposed to study on the frequency-related matters for identification of IMT in 5925 to 7125 MHz on WRC 23. Multiple countries joined to submit this contribution, including the Afghanistan, the Cambodia, Laos, Mongolia, Nepal, and the Papua New Guinea. And next slide, please. In our view, 6 GHz is the most promising beyond 5G and 6G spectrum. Currently, the mid-band of globally harmonized spectrum for 5G deployment are 2.6 GHz, the C-band 3.5 GHz, and 4.9 GHz. In the coming years, the UHD and HD video and VR, AR will become the dominant service for users. Not only the resolution and refresh rate of the screen will upgrade rapidly, the watch time consumption is also increasing very fast. Driven by the above factors, it is expected that users' monthly DOU will continue to grow substantially, and in some advanced markets, it might exist 100 gigabyte in 2025 and 250 gigabyte in 2030. So with existing 5G band and legacy 2G, 3G, 4G spectrum, there is still spectrum gap to meet the capacity requirement. Taking the spectrum efficiency, the network traffic load, a user penetration rate, DOU, as well as the set density into account, it is estimated that additional 1.3 to 1.6 gigahertz spectrum is needed to fulfill the spectrum gap. And compared to the millimeter wave, the 6 gigahertz has better propagation and coverage characteristics, assuming the unlost outdoor propagation condition. To achieve downlink 100 million bits per second and uplink 1 million bits per second data rate at the edge of the cell. The downlink coverage of 6 GHz is 277 meters, which is over 5 times compared to a millimeter wave. And the uplink coverage is 320 meters, which is 10 times compared to millimeter wave. And with the developing of innovative technologies such as larger massive MIMO and new moderation scheme, the coverage range of 6 GHz can be close to 4.9 GHz. So 6 GHz is only remaining middle band with 1.2 GHz contiguous available spectrum to provide the continuous coverage. And as a supplement, coordination with millimeter wave band can provide a high capacity enhancement in some high traffic demand areas. Next slide, please. And so from a China Mobile perspective, we believe that 6 GHz is the future IMT golden spectrum. And China Mobile will work together with the industry to drive the 6 GHz spectrum as global harmonized beyond 5G and 6G golden middle band, including the coexistence and innovative technology study, standardization in 3GPP and RTU, and promote the maturity of the ecosystem. Thank you.
Thank you very much, Chang from China Mobile, for your excellent presentation. Next, I would like to give the floor to Satish Jamadagni from Reliance Jio. The floor is yours. Tian, we will jump to the next speaker. The next speaker from Axiata Group, Mr. Hajar Saad. Hajar, the floor is yours.
Can you hear me well? A, B, C, D,
yes.
E? All right, excellent.
Perfect.
All right, thanks, Christian.
Thank you.
First of all, I would just like to thank the organizer for inviting Axiata to be part of this webinar to share our views on the opportunities of 6 GHz in APAC region. Now, being the among the last few presenters has its advantages as well as its disadvantages. I know that most of the things that I want to say or should say has already been covered by the line of excellence presenters before me. So just please bear with me, and I apologize in advance if I'm beginning to sound like a broken record to you. For my brief presentation, I would focus specifically on how Axiata sees 6 GHz as an opportunity that the APAC region could definitely tap on. Next slide, thank you. Just a brief introduction of who Axiata Group Berhad is. We are an Asian group of telecommunication company. We are based here in bright, sunny Malaysia. We have operation across 11 countries, mainly in Southeast Asia, as well as South Asia market. We have a diverse portfolio ranging from mobile network operation, communication infrastructure services, as well as digital services. Next slide, please. Now, straight to my point, Axiata strongly believes that 6 GHz spectrum band presents a great opportunity that the APAC region can definitely leverage on. One, 6 GHz being a complementary band to the existing or current mid-band spectrum for IMT. Now, if you looked at the growth of mobile traffic, it has always been on the inclining trend. And we believe this will continue to be so in the future, particularly with the 5G traffic starting to pick up. And as we know, 5G requires operators to have access to low, mid, as well as the high spectrum band in order to meet the very stringent requirements of 5G services. Specifically in the mid-band, 3.5 GHz is the primary spectrum for early 5G deployment for now. So therefore, for operators, or if we are expected to accommodate that exponential growth of mobile data traffic, we require access to more spectrum in the mid-band, and we feel that 6 GHz is a great complementary spectrum just to do that. And in addition to that, we see that 6 GHz offers an attractive solution to APAC region, particularly in markets where refarming sufficient mid-band spectrum is challenging. This is particularly the case in the markets that we're in Southeast Asia market, where the 3.5 GHz is extensively being used for fixed satellite services. Therefore, making available a sufficient spectrum. By sufficient, I mean offering, allocating 100 megahertz of contiguous spectrum per operator can be a bit of a challenge. Hence, we feel that 6 gigahertz could help to alleviate or address that limitation. Secondly, we see that there is a significant advantages from an economic standpoint to support a wider 6 gigahertz identification for IMT. As we know, cost of technology in terms of network investment by operators and adopting new technology from consumers' point of view is one of the key or driving forces to determine a success of a network service. Under the WRC 23, only 100 megahertz block of 600 ranging from 7025 to 7125 is being considered for global IMT identification, while the region 1 has taken a bolder approach to consider a wider 6 gigahertz identification with an additional 600 megahertz ranging from 6425 to 7425. We feel that there is an opportunity here presented to the APAC region to support a wider IMT identification, which would enable us to leverage on what could we feel potentially become a larger ecosystem created from region 1 adoption. So by being part of that larger system, it essentially means that we could drive the economy of scales for cheaper devices and cheaper equipment, which would be great for both consumers and operators. And again, this is something that emerging market or developing markets in the APAC region would want to benefit from. Next slide, please. Now, if the APAC region is serious about 6 gigahertz spectrum band, I think the work needs to start now. It is a well-known fact that spectrum policy is a long, complex, and at times can be a daunting process. Essentially, there are 2 stages that we need to address. One being the allocation process via World Radio Conference, where an IMT identification under the WRC process typically takes around 2 cycles, which translate to about 10 years of work, with the first half trying to get into the WRC agenda item, and the remaining half is the actual IMT identification itself. Now, once that's done, you have the national agenda process to deal with. This is another long, complex, and daunting process. It can even be a longer a more complex and a more daunting process when we have to deal with incumbency issues. Now, just to give you an idea of how long that process could take, especially in the markets that we are operating in Malaysia, the clearance of 700 from broadcasting services took us roughly close to 4 years. Malaysia has completed its GSO in October 2019. But despite that, and of course, for various reasons, 700 megahertz remains unallocated until now. In Indonesia, years of tussle within the government and years of campaigning, I think it was quite close to 10 years. The Indonesian government has finally agreed, promulgated ASO end of last year's. By the way, a footnote, a special thanks to GSMA for their relentless effort in pushing this agenda through. Thank you. So now the Indonesian government is aiming to complete the ASO within, inshallah, 2 years. Again, we are facing similar situations, having to manage with incumbency issues with 3.5 gigahertz in both markets. Whereas in South Asia, Bangladesh, Nepal, we are talking about the current IMT spectrum, such as the 900, 1800, as well as 2100, being not yet fully allocated to market, hence creating artificial scarcity in the markets. And we could talk about that. It could take a whole webinar session just talk on artificial scarcity in the market. What all this means is that again, spectrum policy is a long, complex, and daunting process, which could only mean that the sooner we act, the better it is. And as far as how this could fit into the WRC process, I think ideally we would want the APAC region as a whole to identify a wider IMT identification in the 6 gigahertz. But if anything, I think history has taught us that for such thing to happen, you may require divine intervention. But I'm not saying it's impossible. I think a member state can always opt to add their names into the footnotes, again, taking advantage of a larger ecosystem as what we have seen with 3.5 gigahertz. On that premise, I think we have a lot more work that needs to be done to continue putting pressure or emphasis on the importance of 6 gigahertz to the APAC region, especially in trying to convince the regulators or governments that access to a wider 6 gigahertz is crucial for mobile sector to continue thriving, which eventually would benefit the region as well as countries as a whole. So the work needs to start now, if not yesterday. With that, I end my presentation. Over to you, Christian. Thank you.
Thank you, Hajar, for your excellent presentation. Some very important points made in there, especially the importance of timely planning and not leaving this type of work for later on. Especially coronavirus have taught us that the need for reliable and high quality infrastructure makes a huge difference, and connectivity is what keeping currently our economies going. So now we are going to see the effects of increases in data consumption and the need for more mobility. So therefore, we need to plan for that. Thank you very much, Hajar. Our next speaker will be Erika Tejedor from Ericsson. The floor is yours.
Hello, good morning. I hope you can hear me well.
Yes, we can hear you well. Thank you.
Okay. Good morning. My name is Erika Tejedor, and I'm part of Ericsson. I will do this presentation together with my colleague Ayman Mohieldin from Nokia, and we are representing Ericsson, Huawei, Nokia, and ZTE. Next slide, please. So we like to start by talking about 6 gigahertz and why 6 gigahertz and not any other band, and why do we need more spectrum? First of all, I think that's the first question that we need to answer. The reason is because if we look at the spectrum as we have it today, and considering the spectrum that will be needed for the future, if we look at the time frame 2025-2030, we see that additional mid-band spectrum is going to be needed, and that's to address the IMT 2020 user experience requirements that have been defined by ITU, which are 100 megabit per second in the downlink, as well as 50 megabits per second in the uplink. Then now that we know that we will need spectrum, the question is why 6 gigahertz is so important. And there are several reasons for why we are considering the 6 gigahertz as a candidate band. One reason is this is globally allocated to mobile service. That's always the first step to use the spectrum for IMT technologies. The second reason is because we are looking for additional spectrum that has a good balance between coverage and capacity. And we have been, in the last years, we have been talking about 3.5 gigahertz a lot, and 3.5 gigahertz has been released broadly across the globe. So we have been looking for a spectrum that can give us similar possibilities to the 3.5 gigahertz. And that is something that can be achieved with the 6 gigahertz. That is thanks to the improvements that we see with both the base station and the UN enhancements, because obviously there is certain gap in terms of propagation loss. Another reason is the large contiguous blocks that are available in this spectrum range. We have to remember that if we look at this band as it is being considered for WRC23, that's 700 megahertz of spectrum. And if we go even lower in frequency, down to 5925 megahertz, we have 1,200 megahertz of contiguous spectrum, which is very difficult today to find in the midband range. And we see for this band a potential for wide economies of scale. Next slide, please. Looking also at the use cases for this band, I think this is also a very important thing that we have to look at. As I said earlier, the 6 gigahertz is a very good balance between capacity and coverage, and we are envisioning the usage of 6 gigahertz similarly to the 3.5 gigahertz, and that means, of course, that this band is also envisioned for the same use as the 3.5 gigahertz, and that is high capacity citywide coverage. So when we look at all the different use cases here, you can see different colors in the slide, and the different colors really define the different type of usage. So this band is very important to address the future needs of the city, high capacity in cities, and also how high capacity including mobility, which is critical in the cities. No one wants to lose the signal when we are using our phones. That would be in the sense of EMBB. But this band is not only envisioned for EMBB. There are other many use cases for 5G, and there are other many use cases that are very important for this frequency range. So, for example, we can think about V2X, and there you can see in the picture also in pink color. And another very important use case that we envision is fixed wireless access. While we see that the spectrum will be very much used for mobility in the city, we also envision this spectrum to be used outside the cities. And of course, using the spectrum on an optimal way is very important from a spectrum engineering perspective. And this spectrum, as it is key for mobility in the cities, we also see the importance of this spectrum for fixed wireless access outside the cities, for example. Another use case that is very important outside the cities is smart manufacturing. And also this spectrum is very important now that we are talking about mobility, and we always want to be connected. And there has been a lot of discussions about transport. This spectrum is also very important for transport paths. Next slide, please. Now moving to the 6 gigahertz ecosystem. There are 3 different big activities ongoing at the moment. We have the ITU. We also have work in 3GPP, as well as we have work ongoing within the industry. So in terms of the ITU, we are at the moment still setting the parameters, and we will be doing that until the 15th of June of 2021. After that, we will be working on sharing studies all the way to CPM. And of course, after CPM is finalized in 2023, we will have also the WRC 23. That will be really when we take all the decisions. In 3GPP, there is also work ongoing. And there is, at the moment, there is an agenda, a work item for 6 gigahertz. This is covering both 6425 to 7125 megahertz, as well as going down all the way to 5925 megahertz. And if we look at the industry, this is also very important to indicate there are field trials already planned for next year by the IMT 2020 group in China. And that will be to already test the 6 gigahertz. So that really gives us the whole picture of how the ecosystem is moving, and it's really giving clear indications that there will be an ecosystem ready when the decisions are taken at WRC. Next slide, please. Looking also at the characteristics of the 6 gigahertz, we talked a little bit earlier that 6 gigahertz and 3.5 gigahertz are envisioned in a similar way. And here you can see some facts and some simulations that we have been doing, just to show you that it is indeed possible to have a coverage that is similar between the 3.5 and the 6 gigahertz. And that you can see in the graph on the right side, where you can see the CSI received power at the UE, and you can see the two different lines, the blue and the red curves, where the 3.5 and the 6 gigahertz are quite close to each other. And this is indeed being allowed thanks to the technology advancements that we have with 5G and the propagation laws that differs 3.5 to 6 gigahertz can be compensated by our technology. Next slide, please. And with this, I think I leave the word to Ayman. So Ayman, the floor is yours.
Thank you very much, Erika, and for presenting the first half of the slides. I'm going to take you into the consideration of the WRC sharing studies, which is currently starting, and we are waiting for the parameters to be added. But before starting the sharing studies and doing the technical studies, we have to think about what are the major incumbent services in the band, in this 6 gigahertz band, and which are the first of them is a fixed services. And when we are defining the sharing studies, we have to define also along the parameters what kind of sharing scenarios we are going to envisage in this one. So, and this is take us into the consideration, for example, what are the kind typical application. And for example, for the fixed links, the typical application, this is our mostly a long hop or long distance links that are suited in rural and development or remote areas as well. It had a known location and known characteristic, and they are one of the applications is mobile backhaul plus also some kind of broadcast networking. And even the assignment is link to link. So you also could think about this. If you can see in your right hand side, you can see two scenarios that are currently envisaged, is that how you can develop the sharing scenario. And this is just a starting point because the WRC sharing study have not yet been studied, but this is only just an initial and let's say initial studies to see how it looks like. And it defined a typical scenario how to do those sharing studies, and from out of those studies you can see that there could be also a possibility and visibility to have a coexistence between the IMT application and the fixed surface application and coexistence. One could think about a toolbox or a mitigation techniques and solution to help both surfaces to coexist with each other. And these things like, for example, you can have a coordination like spectrum sharing or a case by case, how you do your network planning. Maybe you can develop your link in that place or that other place. It depends also on the antenna position and the parameters. So, and there could be other parameter and other things about it. Alternatively, also it depends on the operator what they want. If they want, they can also migrate and how many links they are having in that band. They can also think about to migrate it to other band if there is a possibility. So in that sense, such a kind of thinking and initial analysis could help us to think about how to develop the sharing scenarios and how to do the coexistence within the ITUR and WRC23 process. This is for the fixed services. If we look into the other hand, can you turn to the next slide, please? We have other also a major one, which is a fixed satellite service. And it's in the uplink, and it's important to protect it. It's important to protect it because this is a global issue. We need to protect the fixed links, the FFS links in the upper one. And this will be done through the ITUR process, and it's important that we are going to contribute and committed to contribute. But on the other side, you see that there are different 3GPP ecosystem that are existing in the mid-band region. And this are like interleaved with this 5.9 up to 7.15. They are interleaved because you find a downlink in one of those places in those ecosystem which is already developed, and you can find that at the same time you can find it also being an uplink to other band. And this is highlighted on those yellow and purple things, how this been done. So we have some observation on the study towards WRC23. We know very well, we had the study done in 2015 time. There are several studies have been done, but currently there is advances in the technology, and these advances in technology will help much better to coexist with satellite. For example, you can think about adding an active antenna system and beamforming to the IMT system that could precisely tell you how you can direct your signal, such a kind of a thing. There is also some current done in study group 3 in ITUR about developing a new clutter laws and building entry laws and propagation models. This also could help to understand the environment. And all, we just inviting and recommending that to take into consideration those advances of technology into consideration when we are dealing with the sharing studies in the ITUR and WRC23 process. Next slide, please. So in a sum, we are recommending that for the 6 gigahertz, that for the lower part of the 6 gigahertz, it's a decision or consideration depending on the country situation and how they would like to utilize this band. But for the upper band from 6.4 up to 7.1.5, we think this is a great opportunity to do the sharing studies, to see and to give this band for an IMT services to satisfy the different use cases that it needed. This will impact the life and the business and also impact affordability of the services in this mid-band spectrum. So I think WRC is a great opportunity to harmonize this band, and there could be several ways how to do this harmonization in the APAC region. What could think about, we have 100 megahertz, this could be available, but also we have additional 600 megahertz. This could be done through different regulatory measures. From here, I would say thank you for listening to our conversation. Thank you very much. Iman.
Thank you very much for the excellent presentation. I now would like to move to the next session. I think that our previous speakers were all excellent, and we were very fortunate to have them today in our panel. So I would like to now briefly talk on behalf of the industry in general, and also on behalf of our previous speakers as well, from the different industry sectors that we have now explored through different presentations. So when it comes to 6 GHz band for IMT, we do have an industry view in a cohesive way. For us, the International Mobile Telecommunications IMT system is the efficient way to provide broadband wireless connectivity on a worldwide scale. And this standardization system and current work greatly contributes to the global economic growth and social development. So we encourage the continuation in terms of the efforts in growing the IMT set of standards and associated identifications for their use. IMT technology development and deployment will continue to create a large amount of employment across the world, and will also contribute to GDP growth. We also think that 5G is a pillar for digital transformation, and enhancing mobile broadband and enabling new use cases is a priority for innovation. 5G connectivity is also essential for the development of new information technologies such as IoT, cloud computing, big data, artificial intelligence, AI. These developments are particularly important as the amount of data that society generates continues to expand. Therefore, we need to find ways to efficiently manage data, and connectivity is a key part of that. The user mobile data consumption, as we have seen, is increasing and will continue to do so for the coming years, because this mobile data consumption is not just generated by humans, but also more growingly by systems and machines and devices. More spectrum is needed for 5G to meet the future network capacity and coverage demands for citywide use cases, especially when it comes to mobility. In particular, the 6 GHz frequency band is a natural and strong candidate that offers seamless high capacity for the citywide context with licensed spectrum, from which we can get reliable communications, highly secure, and well as providing certainty for investment. As we all well know, licensed spectrum provides that platform for coordinated use of this resource, and coordination is key, and part of that coordination is the licensing system. The WRC-23 preparatory work has started already across all regions, within the ITUR, of course, and we need to continue working across all regions, especially here in APAC, to secure a possible identification in the 6 GHz band for IMT, alongside with the standardization work that is taking place in 3GPP. And to close off this industry corner session, I would like to highlight that we recommend policymakers and stakeholders to carefully assess the opportunity that IMT identification in the 6 GHz band provides at the WRC-23, which will be very important to establish the large-scale ecosystem for this band and to keep up with the demand that is emerging, especially post-COVID-19. So with that industry statement, I would like to move to the next session now, which is on question and answer. There are a number of questions that have been formulated. Yes, Tian, please go ahead.
Yeah, thank you. Dear audiences, as we are running over time, and we do appreciate your patience and we do appreciate your time, and we would like to extend the meeting to take 2 questions only. And thank you. Please go ahead, Christian.
Thank you very much, Tian. So we will take 2 questions. Well, we have to make various choices when it comes to questions. So I'll go to the first one. I will just read out loud the question just a moment. So the first question is, should the 6 gigahertz band be unlicensed? So that's the first question that audience would like to address. So from our panelists or Tian, who from our panelists would like to take that question?
Can I take that question? Is this
Sure,
Erica?
Erica. Yes, Erica. Floor is yours. Thank you.
Okay. Thanks. I think that's a very valid question, considering the discussions that we are having at the moment. And I think one thing that we have to consider is, of course, all different applications have needs. And as we are showing our needs from the mobile perspective, I'm sure there are needs from the unlicensed perspective. However, I think that the choices when administrations come to the point to make them needs to be really considered. I think one important aspect for administrations to think of is that choices when it comes to license exempt are not reversible. So that means that if there is a decision at the moment that it's being taken for license exempt usage, if later there is a decision that maybe it should have been used for mobile, this is not something that they will be able to revoke, because once the devices are out there, then there is no way you can just take them back. So our recommendations is that countries really assess their needs for both licensed and license exempt. This is considering also the spectrum that is already available today. For license exempt, there is quite some spectrum available in the mid bands with the 2.4 gigahertz and the 5 gigahertz, and there is also quite some spectrum on the high bands. And there are different factors also, not only the spectrum needs, but also different factors that need to be considered by administrations. When there is a decision on a license, there has to be also a consideration of how much fiber there is in the country. Because we have to remember that to be able to get gain from having additional unlicensed spectrum, you need infrastructure to deliver that speed. So additional spectrum for unlicensed usage requires also to have a very good infrastructure to deliver that speed. Then another thing to consider of is investments. If we have a license decision, we know the investments will come from MNOs, and especially if we have some kind of bidding. However, there has to be considered also, if there is a decision for a license, where are the investments going to come from? And to, again, especially for the infrastructure that needs to deliver the speed. And last but not least, we have talked over the past years a lot also about industry applications, and these are users that are requesting a spectrum. For that, we need quality of service. So if there is quality of service that is one of the requirements for the 6 gigahertz, then again, we come back to a licensing regime, because that's the only way of securing quality of service. So just summarizing the answer to the question, our recommendation at the moment is to, especially for the upper part of the band, to wait for any decision and see and follow more the process towards the WRC, so that there are no decisions being taken that could have an impact on the WRC process and decisions.
Thank you very much, Erica. I see Stefan as well. Stefan, would you like to contribute as well to that question?
Yes, I think Erica already rightly identified the economic aspect, particularly in emerging markets where there isn't a good fixed line infrastructure, and it would be unaffordable assigning or making the entire band available for IMT would bring very large economic benefits to countries such as India, Pakistan, Vietnam, Indonesia, and so on. And already today, when you look at Wi-Fi speeds versus 5G speeds, the latest research shows by OpenSignal, for example, that 5G delivers a greater speed than Wi-Fi in all markets except the United States.
That's a very telling factor. Thank you, Stefan. Tian, do we have time for a second question or not?
I think the second question is rather simple, and maybe we can directly take it from the chat room. We can take the question from the chat room, and I believe I am able to answer it. So the question will be, will IMT at 6 gigahertz be used for outdoor to indoor coverage too? And the quick answer is yes, it is going to, yes, it is. And it's a similar approach as for C-band with a similar motivation, as we need to reduce the cost transmitted bit when targeting citywide urban and suburban coverage or FWA in rural areas. And I think that would be the answer to that question too. And yes, I think we don't have too much time.
Thank you, Tian. So I'll hand over to you then for the closing part of the webinar.
Right, great. Okay, thank you, guys. And this, thank you for participating in the 6 gigahertz for IMT opportunity for society. And please stay tuned with us. And there are future webinars planning on similar topics as well. And thank you for your time. And the webinar is now over. Thank you.